back to the stat button. Edit. Stick Ernie's data in L1 and stick Bert's in L2. So Ernie was 81, 82, 79, oops, 79, 80.
Did it enter each time?
Enter or down, yes sir. Enter or down each time. Doesn't matter what order you put it in. Irrelevant, completely irrelevant what order you put it in. The TI can deal with all that crap. L2, stick Bert in there. He had 100, he had an 82, 94, I think.
Yeah.
Looks like 68, 61. Thank you. Fantastic. Fantastic. And this is about to Sherry, what you said about the order of them. I don't care what order you put them in, because I'm not going to subtract them across. That's one thing we do in 244. We try to see like a pre and post test to see if anything changed, and we'll actually subtract them in L3 and put the differences in there. For example, we'll test to see if your thumb or your forefinger is faster working a stopwatch. We'll check the energy bracelets. We mentioned that last time. We'll check the energy bracelets by seeing if a jump was different with or without. But we're not doing that right now. We're analyzing them independently of each other. Cool so far? Okay, now you press your stat button again. We're going to go back in there and we're going to get Ernie's statistics again. We're going to run Ernie again just to show you how nice this is and how much time this saves. Okay, so over to the calculate menu now. Over to the calculate menu. There's a lot of stuff in this menu. If you had me in 105, we dealt with like half of this menu. And we're not going to deal with only one element in this menu, and it's the very first one. Corbin, go, please.
I've got a TI 89.
Give me 5 seconds after class with you, I'll show you where all this stuff is. Just hang tight right now and get the language down, and I'll show you where all that stuff lives. 5 minutes tops. I said seconds, I meant minutes. Probably not even 5 minutes. Over 1 to calc, for calculate. 1 var stats is the only thing we're going to use in this class. What do you think that stands for? Var actually stands for variable. It makes it variance, because I got that plugged in your mind now. Variance. It's actually variable. Single variable. What's the single variable we're analyzing right now? That's part of the parcel, but what was the original data we were looking at? His test scores, his points on his test scores. That's the single variable, his exam scores. Now the deviations are part of that analysis, but the single variable we're talking about are actually his test scores. If we were looking at 2 var stats, we might want to be correlating his first and second exams and see if there's any kind of a pattern. We're not going to do that. I'll do that in 244, I promise. Cool? So grab it. And when I say, there's Sean language too. Whenever I say grab it, it means press enter. So apologies. You'll hear things like scooch. Scooch means move left and right. Grab it means enter. You'll figure it out. Press enter. Grab
How do you go back?
it. Back to where?
I don't know, I think I can.
Just press the stat button again. And then grab what you want, 1 var statistics. And press enter, and you get a screen full of stuff. Tell me what you see.
Not that.
Average?
Not that. You do actually, believe it or not. But good. You see this guy right here? Yay, us. No more adding and dividing. Yay.
The total where you got.
This guy right here, summation of x. That's when you did the average, you had to add them all up, right? And then you divided by.
And which is 5.
Which is 5. Good, very, very good. I'm gonna put light lines through them. You don't need them very often here. I'm not gonna say they're not ever useful to us, because sometimes they are, but right now they're not that useful to us. You know what this guy is right here? If you were to take all of the exam scores and square them, and then add that up, you'd get, what is it, 32,815. You can go ahead and strongly cross that one out. You're never going to use that here. I'm not even sure why the hell it's there, to be perfectly honest. Except back in the day, students had to calculate standard deviations manually. And there is a shortcut using that. I'm guessing that's why it's still there. Nathan, go!
Is that summing all the numbers squared individually, or is it
Yes.
or is it squaring them and then adding?
Good question. Nathan's question is this thing I just crossed out, is that squaring the numbers and then adding them, or adding them and then squaring? And it is squaring and then adding. If you had to sum them and then square them, it would have to be that,
Okay.
which would be that, which would be much, much larger than the other one. It's because this is actually part of that. But needless to say, friends, honestly, both of those are fairly meaningless for you guys, especially at this stage of the game. You can ignore it. It's left in there. I think it's a remnant from the old days, from when we did everything by hand and we ate dirt and we liked it. So you can just ignore it. And go straight to our friend. Do you see who our friend is? There's your 11-3 that you mentioned before, Nathan. There he is in there. That's your friend right there. That's the reason we like this menu, if for no other reason. Now, there are other reasons as well, but that's the main reason we like it. We like that because that gives it to us without running through this thing that's behind it. That scared y'all off about 10 minutes ago. Yeah, seriously, thank God. Now, this guy under him, I'm going to mention him now, we're going to come back. That guy right there is little sigma x. That's lowercase sigma, not capital sigma. I think I might know what's going on over here. Can I check real quick? I think, yep, I'm going to make it look like this. It's just, it's a problem that TI fixed that didn't have a problem. And turn that off. There we go. Now it looks just like ours. Yeah, if anybody has a newer 84 and the screen doesn't look like ours looks, yeah, one of our stats now, just press enter. There she is, yes? Boom. Yeah, absolutely. If anybody has an issue getting this on an 84, again, see me after class, we can fix it in like 5 minutes or less. Anyway, back to this. This is lowercase sigma. I'm going to introduce him to you briefly. Hello. How are you, lowercase sigma? What that is the population's standard deviation. You guys learned about it in physics, it sounds like fantastic.
Is that how the symbol looks like that?
It looks more like this, like a sideways 6. But here's my objection to talking about it right now. Number one, is it a statistic? Or is it something else? It is something else. That's one of those leading questions, I'm sorry. I try not to do those too often in here, but this is so weird that it doesn't. It's not a statistic. If it's not a statistic, if it's a measure of a population, what do we call that? Do you remember? Good! We get it via a census. Thank you, Lauren. Yes, if you have to go out and do a census to get it, and then it starts with a P, ends with a parameter. That's right. It's called a parameter. You do not get parameters. Because in order to get a parameter, you have to do a census. Now, the reason the TI has this one right here is it's saying, Sean, just in case those 5 data points were your entire population, that would be the standard deviation of your population. You can go ahead and ignore that because you're never going to have little sigma because you're never going to have your population. You guys do it in physics all the time legitimately because your samples are so freaking large that you can pretend it is little sigma, essentially. Our samples aren't anywhere near large enough to do that with. So that's why it's essentially the exact same computation on large data sets for small ones, as small ones, but we get, as the smaller they get, the more deviant they get from each other. Oh, lost the screen, hang on. So far, the only 2 things that are important for you guys, get your average and get your sample standard deviation. Everything else is kind of just happenstance for the time being. But look, there's more. Little down arrow, go look, go down. Yes. What other goodness is down there? Your smallest data point, 79, you knew that. Biggest data point, 83, you knew that. Look in the middle. You get your median. Yay! No more sorting data. This is why I told you it doesn't matter what order you put it into L1. It's going to sort it for you and kick out your median. Yay! You don't share my excitement. That's okay. It's all right. You also get the Q1 and Q3. I want to come back to those guys. They make more sense in a different context, so let's just leave those alone for right now, although they are important. Did you guys talk about quartiles in physics? Okay, good. We'll get to that in a little bit. So right now, you got 3 things that are kind of like, yay. We got the average, we got the median, and you got the sample standard deviation.
But that's just an L1, right?
That's just an L1. We haven't talked about BERT yet.
Okay.
We haven't gotten to BERT yet. We're going to get to BERT soon. Because we have to test these theories about 15 and 20 and 16 and 19. All these theories. Let's see who's closest.
But you entered in both of the information.
We did, which means the TI, when you type 1 var stats and press enter, only looks at L1. So now let's look at BERT. So back to stat, calc, 1 var stats, okay? Don't press enter again, because you press enter again, it's going to go right back to L1. You've got to tell it to look at L2. How do you type in L2? Second 2. Second button, which on mine is blue, some of them are yellow, depending on what model you have. Press the second function or the shift key, whatever it's called. then press the number 2, and you'll get L2 pop up. This is how you get L2. You don't have to give it L1 because it automatically knows to look at L1 in one of our stats, but you can override that. It's called by default. By default, it goes to L1. You can override it though by looking at L2, press enter, and some of this might look the same as the previous one. You're like, wait a minute, timeout. The average is 81 again. Well, that was the whole point. An hour and a half ago, you figured that out. That average of Bert and Ernie were both 81. You're like, oh, that's you can't tell the difference between it. Good. So you'll notice that the sum of x is also 405. That's because that divided by that gives you that. So you can ignore that again, because it's not really important right now. You can also ignore that. This. Finally, Lauren, 20 minutes later, we answered your question as to how can you compare Ernie's 1.58? You can compare it to that. Bert's is much, much, much wider. On average, he's about 16.6 points away from his 81, where Ernie was only 1.6 points away from his 81. That's a great measure of variation. It's kind of like the gun going, you're still averaging 81, but my God, they're all over the place getting to it, where Ernie's going, that's a way to quantify it. That's a way to quantifiably measure that variation in their scores. Richie, go, please.
I've got to think about where on measures of center versus measures of variation do we start?
Never separate them.
Never separate them, but what happens if he was over here, but he's all over the place?
That'll tell you. I love that. What you're talking about is accuracy versus precision. There's two things that are really being worked on here, accuracy and precision. Now accuracy, in order to test accuracy, you have to know what you're shooting for. So like with the marksman or markswoman idea, it's easy. There's a bullseye, you're shooting for the bullseye. If you are clustered tightly around the bullseye, you've got high accuracy and high precision. If you're clustered around the bullseye, but you're much, much wider, you've got high accuracy and low precision. If you shot the wall a few times in a very tight cluster, and the bullseye's over here, you got low accuracy, but high precision. And if the bullets are, then you got low everything. No precision, no accuracy at all. So the idea is, accuracy, if you want to think about it, is the measure of center. And precision is how spread out your values are. So basically, that's why I like looking at this, because it gives you both. It gives you that center idea, and it gives you the spread idea. And that's why I think these two things should always go together. More on that to come on Thursday. I think we've filled ourselves up for the goodness in one day. But I want to start pairing these things up and deciding what we can actually decide about these things. Like, okay, great. We now know that Ernie is 1.58 points away from his average, where Bert is 16.58 points away from his average. So what? All that tells us is Bert is inconsistent. But actually, it can help you decide which plan you should buy from Ben Broadband as far as data goes. If you have an idea of what your data looks like from past usage, you can say, I wonder if I should upgrade to that higher plan. You know, Ben Broadband, you sign for their data plan on your phone, whatever. And sometimes you get dinged with overages. They get dinged with overages. So the one thing about overages, when should overages happen? Should they happen all the time? If they're happening all the time, you're in the wrong plan. And that gets expensive. Because if it happens all the time, that means you're paying extravagantly for when you go over a little tiny, tiny bit. So what you want to do is you want to analyze the variation and say, okay, if I'm within this range 99% of the time, maybe I don't need to go to the next data plan up. I might get dinged once every 100 months or something like that. But that one ding is cheaper than paying extra every month for the other 99 that I don't need. That's the kind of question we haven't answered yet. So Lauren, although we've kind of skimmed the surface of your question about, you know, okay, so 1.5 versus 16.5, great. How can we use that to actually make a call on our behavior as a result of that? We have not even begun that yet. Well, we have, we began it today. But we haven't figured out how to do what to do with it yet, which we will do, because we can't do it in 5 minutes. Let's do it on Thursday. Yeah? Good? Sorry, that was the first like real math we did. I apologize. I try to keep away from you guys whenever I can. The big idea is knowing what those numbers mean, and you do know what they mean. Average distance from average. Boom! That's the takeaway from today. We'll put it to work next time, yes? Corbin, let's figure your TI out, yes?